So good morning. Welcome to lesson 2. I'm in a new location with a little more light, and you can see behind my shoulder I have Einstein, Da Vinci, and Socrates are taking part in the class. And in all my class, I try to start out with a real life math story that shows how important math is in the real world. And here is today's story. It's about a doctor slash scientist in the 1950s who is a hero, and unfortunately, almost nobody has heard of her. I've given this presentation for about 20 years, 100,000 people maybe, and only one person has heard of this doctor. And it's unfortunate because she's a woman hero, and our budding scientists and women doctors need more heroes to look up to. And her story shows how math can be interesting, challenging, and important. And here's her story. 1956, leukemia was on the rise in young children. If you don't know what leukemia is, it's a kind of cancer of the blood. And so many children were getting it, hundreds and hundreds more than expected. Some people were calling it an epidemic. And unfortunately, it was happening in countries with better medical care. That was very ironic, that the countries with the best medical care had the higher rates of leukemia. So Dr. Alice Stewart, she decided she was going to try to get to the bottom of it by crunching some numbers, doing some research. So what she did, she interviewed the mothers of children who had died of cancer about events from the time of conception, and she also interviewed a control group of mothers whose children did not get leukemia. So what she found when she crunched the numbers was something very dramatic and very unexpected. She had no idea she would find this, but the numbers pointed to almost certainly what was causing this leukemia epidemic, and it was the children who died of cancer were more than twice as likely to have been x-rayed before birth. So what was happening is pregnant women would go into the doctor, and the doctor would give them x-rays to see the sex of the baby, how it was growing. So some women got 2, 3, 4 x-rays during their pregnancy, and the unborn baby was x-rayed also. And you would think the medical establishment would have paid attention to Dr. Stewart, but they didn't. It took years and years for them to finally realize that x-rays were dangerous for pregnant women. And it wasn't even until 1980, before the major medical groups recommended doctors not routinely x-ray pregnant women. And even so, in that year, over 250,000 of pregnant women were x-rayed. Here's another real math story that shows how important math is in the real world. I was looking in a science magazine I have, and there was an ad for a solid gold kangaroo coin. And I've been thinking about investing in gold, but I didn't want to buy gold and put it in the bank in a lockbox. So I thought, boy, this is nice. This is a coin I can display. It has a nice picture of a kangaroo, and it cost $100 with shipping. And I thought, well, that's fine because gold's valuable. But before I send away for the coin, I would want to know how big it is. And there's some hints on the page. And by the way, when we go through this, in this box, I have a coin that I'm going to show you. I didn't buy the actual gold coin because when I show you the real size of it, you'll see why I didn't. But I got a jeweler to make a replica out of brass for $5 instead of $100. So I will show you in a minute the coin after we go through this. So here's the basic investigation. I want to know how big the coin is, because if it's small and I can't display it on a shelf, I wouldn't want to buy it. So the hints on the page are right here. Actual size 11.6 millimeters. And if you're wondering why they put it in millimeters, of course, Americans don't know what millimeters are. So they are sort of keeping the true size in the dark. If they put it in inches, most people would know exactly how big it is. So when you convert 11.6 millimeters to inches, you will get a shock how very, very small this is. And I will show you the coin now. And if you'll notice, I need tweezers to show it to you. That is the size of the coin. I'll put it right here. You can barely see it. This is the actual thickness. It disappears almost when you turn it sideways. Because if you convert 11.6 millimeters to inches, it's less than a half inch. So now let's see, well, it's small, but does purchasing the coin make financial sense? And the clue on the page here is 0.5 grams is what the coin weighs. 0.5 grams. Of course, they put in grams and not ounces because Americans don't understand what grams are. Most Americans don't know how many grams are in an ounce. So the price of gold is about $1,500 an ounce. So let's see how many of these we would need to get before we get an ounce of gold. So there are 28 grams in an ounce. This is 0.5 grams. So we would need 56 of these coins, $5,600, to get an ounce of gold, which is worth about $1,500. So it certainly doesn't make financial sense to do that. So the advanced investigation, you can determine how thick the coin is. I won't go over it today, but it's some pretty tough math to figure out how thick it is, but it ends up being about 1/80th of an inch thick, about the thickness of a 3x5 card. So here is how to turn a boring worksheet into a fun worksheet. So my students, they always hated worksheets, review chapter worksheets, any kind of boring worksheet. They love math stories or things they had to really think about. So I always dreaded bringing in worksheets because they complained. So I decided to change this worksheet into a little different looking worksheet. And I thought they'd see right through it and be bored, but I thought, oh, I'll give it a try. So I took this worksheet and put the heading, Who Wants to Be a Millionaire? Put dollar values down the side, and you can see there's lifelines at the bottom. And my students love these worksheets. Now, of course, it's the same old boring worksheet, but when you have some money values and you have lifelines, it made it a lot more interesting. So here's today's main lesson. It's a very powerful math problem solving technique. The problem I'm going to show you is one you might see on an SAT test, math contest, and most students miss it because they don't know the correct problem solving technique. It's very hard to figure out how to get this correct. So here is the problem. It took 6 people 8 days to build a brick wall. The construction crew needs to build an identical wall but needs it done faster. If they add 2 people to the crew, how long will the brick wall take to build now? Most people look at that, their brain will start spinning, they won't know what to do, but there's a very easy way to do this. It's you have 6 people take 8 days. The name of this problem solving technique is called Think 1. So in this problem, 6 people take 8 days. You want to ask yourself, how long would one person take to build if they had to work alone? So one person, you think about it a bit. If 6 people took 8 days, then one person would take 6 times 8 days, or 48 days. Once you have it down to a unit of 1, it's very easy to figure out how long it would take any number of people. So 2 days, think about that. How long would it take 2 people to do it? Not 2 days, 2 people. 2 people would take 24 days. 48 days is the one person it took for one person. For 2 people, 48 divided by 2. For 3 people, 48 divided by 3. For 4 people, 48 divided by 4. Again, once you get to a unit of 1, it's very easy to get any number of people. So the problem we were asking for was 8 people, 2 more people, so it's just 48 divided by 8, and so 6 days is your answer. You can do very complicated ones with this. Once you get a unit of 1, you can even do 13.5 people. 48 divided by 13.5, 3.56. So Think 1, very powerful problem solving technique. Here's another problem that's very difficult until you use the Think One problem solving method. Now here's one I would give to my students. It takes Sarah 2 hours to paint a fence and Daniel 4 hours to paint the same fence. How long will it take them to paint the fence if they both work together? Most of my students just don't have any idea how to dig in and solve that problem. So a very common wrong answer, they say, if Sarah took 2 hours and Daniel 4 hours, if they work together, it'll take 3 hours. So they averaged them, which is not correct, but I can see why they did that. But then I would say to them, if Sarah can do it alone in 2 hours, how can, when she gets help from Daniel, it take 3 hours? And sometimes they'd be so enamored with their answer, they wouldn't want to change it. And they would say, well, maybe Daniel's annoying Sarah, and that's why it took 3 hours. But no, that's not correct. So think one, think how long or how much of the fence would Sarah paint in 1 hour? Think 1 hour. Of course, if Sarah takes 2 hours to paint the whole fence, she'll do half the fence in an hour. And Daniel takes 4 hours to paint the whole fence, so he'll paint a quarter of the fence in an hour. So together, Sarah half, Daniel a quarter, they paint 3/4 of the fence in 1 hour. So if they paint 3/4 of the fence in 60 minutes, how long did it take them to paint each of those 3/4? So 60 divided by 3, 20 minutes per quarter. But they haven't finished the fence. They've painted 3/4 of it, and it takes them 20 minutes for each quarter. So to finish the remaining 1/4, it would take another 20 minutes. So the answer is 1 hour and 20 minutes. So Think One is a very good use of Think One problem solving technique. All right, so I have a special treat for you. Whoops, I didn't mean to show it to you so quickly. So every day for the next few weeks, I'm going to show you, I have some woods behind my house that for exercise, I walk up and down this hill. It's about a half-mile loop. And I always wondered what is on the trail at night or when I'm not there. So my wife bought me a trail camera, and she bought me a couple of them actually. So I set them up on the trail. And each lesson I'm going to show you some interesting animals that show up on my trail camera. And this is what I found in January on my trail cam. And for those who don't know, that is a coyote. And it looks very, very scary in that picture. I've never seen them when I think they're very scared of humans. So I've never seen them in the 35 years I've lived here, but my trail camera has picked up several, and here's my favorite picture. But over the next few weeks, I have several different animals, and one very rare I've never seen on the property before, not a coyote, but I'll show you that next week. So if you like these problem-solving methods, they come from my book. It's called Becoming a Problem-Solving Genius. Now I'm going to give you some problems to do. And what you should do after I show them to you, pause the video until you finish them, and then when you're done, come back and I'll show you how to do them. So here are the problems. There's 3 level 1 problems. They're not real easy, but they're not real hard. They'll help you get used to the problem solving method. So if you would pause this now, do the problems, and when you're done, come back and I'll show you how to do them. So here are the answers. First question, it takes 5 workers 12 hours to unload 1 truck. How long would it take 6 workers to unload the truck? Okay, again, think one. How long would it take 1 worker? 5 workers takes 12 hours, so 1 worker would take 5 times 12 equals 60 hours. So once you know 1 worker is 60 hours, very easy. 2 workers, 60 divided by 2 is 30. 6 workers, 60 divided by 6 is 10 hours. Number 2, and this is based on the Apollo 13 story. I haven't used accurate numbers here. I just turned it into a problem. But after their oxygen tank exploded in Apollo 13, they had to climb into a lunar lander and hope it had enough oxygen to get back to Earth. So after an explosion, 3 astronauts were forced into the lunar lander. If the lunar lander had enough oxygen to last 2 people for 6 days, is there enough oxygen for 3 astronauts if their journey back to Earth takes 4 days? So we think 1, if it has enough for 2 people for 6 days, then 1 person is obviously 12 days. So now that we know how long it'll last 1 person, 12 days, 12 divided by 3 for 3 people, it'll last 4 days, so they just barely have enough oxygen to get back. Question 3, if 12 workers can dig a tunnel in 100 days, how long will it take 20 workers to dig the tunnel? So 12 workers, 100 days, 12 times 100 is what 1 worker would take. So 1 worker, 1,200 days. Now that we're down to a unit of 1, very easy problem. Just 1,200 divided by the 20 workers. So we can figure out 2 workers would take 600 days, and 20 workers, 1,200 divided by 20 is 60 days. Now I'm going to give you some much harder problems, and after we're done with these, I'm going to give you 1 genius level problem. If you get it right, you can print out an Einstein Award for yourself. So level 2, if you want to pause the video, and I'll come back in a little while and show you how to do these. Okay, here are your answers. Luke and 5 friends packed enough food for a 2-week canoe trip. That's 14 days. So they're going to add 1 extra person. How long will the food last now? So think 1. If Luke and 5 friends, that's 6 people, if it lasts 6 people, the food will last 14 days. How about 1 person? 1 person be 6 times 14, 84 days for 1 person. Now that we know 1 person, we can do any number of people. The food will last 42 days, 84 divided by 2 for 2 people, 84 divided by 3 for 3 people. In this problem, we're going to have 7 people. So 84 divided by 7, the food will last 12 days for 7 people. Question number 2, hose A can fill a pool in 4 hours, hose B can fill the pool in 2 hours. If both hoses are turned on at the same time, how long will it take to fill the pool? Think 1, hose A can fill 1/4 of a pool in 1 hour. And of course, hose B could fill a half of the pool in 1 hour. So it's a little like the Daniel and Sarah painting the fence problem. Hose A does 1/4 in an hour, hose B does a half. So in 60 minutes, the 1 hour, they've done 3/4 of the pool. So together, they fill 1/4 of the pool every 20 minutes. They have 1/4 of the pool left, which will take 20 minutes. The answer is 1 hour and 20 minutes. All right, level 2, problem 3. It takes a crew of 4 painters 12 hours to paint 1 house. If they wanted to paint the house in 8 hours, how many additional painters must they hire? All right, a little twist on it, but same problem solving technique. If it takes a crew of 4 painters 12 hours to paint 1 house, then it would take 1 person 48 hours. So think 1. Once you get down to 48, you can figure out it'd take 2 painters 24 hours, 48 divided by 2. 3 painters, 48 divided by 3. So we want to be able to do it in 8 hours. So 48 hours divided by how many painters equals 8 hours. So that would be 6 painters. So that's the way you use think 1 to solve that type problem. All right, now I'm giving you a very difficult problem. It's a genius level problem. When the drain is closed, a swimming pool can be filled in 4 hours. When the drain is opened, it takes 5 hours to empty the pool. The pool is being filled, but the drain was accidentally left open. How long until the pool is completely filled? So the swimming pool is being filled. Water is pouring into the pool, but also water is pouring out of the pool at the same time. And you want to figure how long it takes for the pool to be filled. So here is the answer. Well, let's go back for a minute. You might want it up there a little bit longer, and then make sure you pause it, and then I'll show you how to do it. Okay, here is your answer. Remember, think 1. The drain is closed, the swimming pool can be filled in 4 hours. So when the drain is closed, think 1 hour how much of the pool is filled. Of course, a quarter of the pool is filled each hour, but because the drain is opened, something else is happening. Some of the water is going down the drain. So 1/5 of the pool is emptied each hour. So 1/4 of the pool is filled, but 1/5 is emptied. So how much is left in an hour? 1 hour, a quarter filled minus a fifth is emptied. So it ends up, common denominator is 20, 5/20 minus 4/20 equals 1/20 is being filled each hour. So if 1/20 is filled each hour, how long does it take to fill the whole pool? 20 hours. Okay, if you got the correct answer on that, print out an Einstein Award and put your name on, collect them, pin it on a bulletin board. And next week, I will be back with another lesson. And I might have 2 lessons posted. I am going to do a lesson on how statistics are manipulated. And I don't want people to be scared off by statistics, think it's boring or difficult. This is a very, very fun class. And it shows you how to look at statistics so you know how to interpret them a little better. But you don't have to be a high school or college student, a 4th or 5th grader. That's pretty good at math. I think we'll get a lot out of this class. So I'll probably post 2 classes next week. One of them will be statistics. So I've written several books. If you'd like to look at any I've written, you can go to my website, or they can be purchased on Amazon. So thank you for joining my class with Einstein, Da Vinci, and Socrates behind me. I think I may add a few more puppets or dolls to my class next week, so look for that. I have a very exciting trail camera picture to show you next week. It's probably my favorite one of the hundreds that I've took. So see you next week. Thank you for watching. I should have classes all spring and summer.